Welcome to clickmyproject.com. Let me discuss the project about discriminating DDoS attacks from false crowds using flow correlation coefficient. In this paper here we are provide a novel method in detecting DDoS attacks. For detecting DDoS attacks we will use flow correlation coefficient. We present a novel flow similarity based approach to discriminate DDoS attacks from false crowds. We propose a discrimination algorithm use the flow correlation coefficient as a similarity matrix among the flows. In one attack session all the attack packets is generated by only one botnet, therefore the fingerprints of the attacks flows are the same. The network delays are discrete and countable. Our extensive experiments confirmed the theoretical analysis and demonstrate the effectiveness of the proposed method in practice. It's the block diagram of our project. First we will load the load datasets. Load datasets in the RC and AE datasets. Then second one is false crowds. False crowds is the two games is separated with both using false crowds. We compared the flow correlation coefficients for two flows in various ways. Two false crowds for the same game, RC1 versus RC2 and AE1 versus AE2. The data sets that we investigated is only two instances of many possible false crowds. The next one is length of flows. Length of flows is the flow correlation coefficient against the length of flows. It performed with the Gaussian and one Pareto flow with different parameters respectively. This indicates that flow correlation coefficient decreases if the attack flows come from different botnets. We found that is general. The flow correlation coefficient decreases when the length of flows increased. The next one is attacker. Attackers is the one who implements DDoS attack to block the website by increasing the network traffic by providing single request, which in turn randomly involves several calls to the website and increases the traffic of the website dynamically. The next one is flow correlation coefficient. Flow correlation coefficient implements the security to the website by defining the modules which contains necessary details such as maximum numbers of passings per request is allowed by the packets. The execution process is then database, then the website keep track of the each and individual packets per request is analyzed. The next one is merged attacks and background noise. Then the website blocks the users for flow minutes. Suppose if the number of packets per request is limited, that allows the users to process up with the normal activity of the merged attackers and the background noise. Now let's see about the execution part. I am having DDoS main.yum file, then select the file, right click, run file, DDoS attacks from false crowds, and select the load datasets. Then data 1 is AE1 data, then data 2 is RC1 datasets. Then next distribution. It's the data distribution and data density. It implements security to the websites by defining the modules which contains necessary details such as maximum numbers of packets per request is allowed by the websites as the threshold value. Once websites in the execution process in the database, then the websites keep track of the each and individual packets per request is analyzed. Then next one is standard deviation. For this one is data 1 and this one is data 2. The next classification by using neural network. It's a neural network train tool. The training scaled conjugate gradient, then MSE values for MSE, then mean squared error, then random values. Then this is iteration process. Then performance is this one. The next one is performance answer confusion matrix are used to the neural network. Then it's the input for training, testing and validation process. The next confusion matrix. Neural network is used to do the feed-forward neural network with one hidden layer, 8 neurons in hidden layer with transfer function. Linear structure default one is neural network rules. Output neurons is segment function. Training iterations is used to do this. In case of feed-forward net with 2 hidden layers, the setting is the same, concentrate to transfer function as well as number of iterations. Number of neurons in hidden layer is at the first hidden and second hidden layer. The next one is number of traffic. Number of traffic in this one is RC1 to RC2 data. Then this one is RC1 to AE2 data sets. The next flows. Flaws, it's the RC1 to RC2 and AE1 to AE2. Then we compared the flow correlation coefficient for two flows in various ways. Two flaws crowds for the same game, RC1 versus RC2 and AE1 versus AE2. The data sets that we investigate is only two instances of many possible flaws crowds. Then next one is graph. Then first of all, it performed to the RC1 to RC2 and AE1 to AE2, then RC1 to AE2. Then the flow correlation coefficient against length of flows, and this one is performed with the Gaussian and one Pareto flow with different parameters respectively. This indicates the flow correlation coefficient decreases if the attack flows come from different botnets. We found that in general the flow correlation coefficient decreases when the length of flows increases. Then next one is SNR, signal to noise ratio. The attacker is one who implements DDoS attack to block the websites by increasing the network traffic by providing single request, which in turn randomly involves several calls to the websites and it increases the traffic of the websites dynamically. The next one is analysis. We tries to discriminate flaws crowds attacks from flaws crowds, which is set of open problem for researchers. We found that DDoS attacks possess higher similarity compared with that of flaws crowds. Flaws under the current conditions of botnet size and organization. We used the flow correlation coefficient as a metric to measure the similarity among flows of flaws crowds. We also discussed the possible anti-detection methods from the attacker's perspective. Thank you.